Good afternoon. My name is Choon-man Jang. I'm working for Korea Institute of Civil Engineering and Building Technology. From now, I'll say some research result on the development of air purification and air conditioning systems with renewable energy for school building. This topic was designed to improve the school's air conditioning and ventilation systems to respond to the problem of fine dust and to save energy for newly built schools. The contents of my presentation are like this. At first, I'll say the background of my study, and then I'll say the air application and the conditioning technology for school, and also I'll say the energy saving strategy for school building. Finally, I'll close my presentation with the future plan. At first, I'll say the background of my study. Recently, fine dust has emerged as a serious social problem. People are more afraid of fine dust than the radiation. In Korea, air purifiers are installed in almost all schools, but there are still many problems to be solved due to system noise, maintenance cost. So in the present study, we'll develop smart system to solve these fine dust problem, noise problem, electricity problem, and maintenance problem occurred in the schools. This figure shows the basic concepts of our research to apply the school. You can see solar panel on the rooftop and the geothermal system at the underground. We consider the central and individual air purification and air conditioning system with renewable energy for optimal operation according to room conditions. In Korea, there is mandatory to apply 30% of new and renewable energy supply in school from 2020. This figure shows the central air conditioning and the air purification systems. Basically, the airflow discharge from the AHU air handling unit is supplied from the classroom ceiling and is designed to circulate through the exhaust port installed on the lower side of the classroom. This system is designed in the modular type to reduce the transport power by installing AH for each floor. This system is generally applied to classroom and teacher's office where energy load fluctuations are relatively small. The figure on the left shows the optimal designed AHU systems. We performed the optimal design of core part of AHU using numerical simulation. The figure in the right shows the streamlines inside AHU. And the velocity vector formed two flow pan. This figure shows the individual system for air conditioning, ventilation, and air purification. This system is generally applied to the special classroom, such as science room and art room, having a large energy load fluctuation. We also designed hybrid filter systems having a low pressure and long life characteristics. As you know, low pressure filter is very important to reduce the system energy load. The hybrid filter consists of charging part of electrostatic precipitator, honeycomb types dust collector, and ozone removal facility. We also consider the optimal airflow inside the classroom. The figure on the left shows the standard school classroom in Korea. There are diffusers on the ceiling and the exhaust port on the bottom of the classroom. The location of diffuser and exhaust port has great influence on the airflow circulation. The optimal position of diffuser and exhaust port are determined by optimal design method using numerical simulation. You can see the computational grid used in the numerical simulation. Boundary condition and the computational domain is right here. This figure shows one example on the optimization of airflow inside the school classroom. The figure on the left shows the distribution of the streamlines comes from the diffuser. The figure on the right shows the distribution of temperature. Relatively higher temperature is observed near the outer window, which is due to the hot outdoor temperature in summer season. All systems installed at the school are operated by integrated control, and offline ventilation is also attempted, such as opening window using Qt door to induce the voluntary participation of students. The signal to open the window by the bearer receives information from the wall pad by the integrated control, and when the window is opened or closed, the emotional notification is used to induce the voluntary participation of the student. From now, I'll say energy saving strategy for school building shortly. We also consider passive facade technology to the school building to block the inflow path of the fine dust by outside door, inside door, and windows. Blockings. The inflow path of the fine dust by the high tide outer window is important in the viewpoint of the energy saving of the school building. This picture shows the changes in classroom door and windows to prevent air leakage. By minimizing the leakage generated from the door and windows, which Wright developed zero energy building and passive school. Finally, I'll say the future plan of our research. We are now designing a mock-up test room to evaluate the performance of newly designed core parts, for example, AHU, EHP, air conditioner, diffuser, and so on. The figure on the left shows the conceptual design of the test room, which has two classrooms and can be tested under similar conditions to the school. The mock-up test room has also integrated control systems considering the installation of real school. Throughout development of the smart facility used for school buildings, we can make a healthy and comfortable classroom in the future. Stages, we will develop the high-performance HU and high-efficiency EHP. We optimize the location of supply and adjust port to optimize the temperature distribution inside the classroom, and minimize fine dust by low-pressure hybrid filter and using eco-friendly building material and make a low-noise fan and duct system. Energy saving of the school building is also considered by efficient maintenance. We introduce optimal control system using integrated control and reduce energy load by passive design. Finally, we induce student participation through the emotional notification using the cute doll. The expected level of the school classroom in the future is here. You can see here PM2.5, CO2, class of the building efficiency, noise level, and integrated control. Thank you for your attention.